My name's Duncan Ross, and I'm the Business Development Manager for the crops sector for Agri-EPI Centre. And for those of you that don't know, Agri-EPI Centre is one of the 4 agri-tech centres set up by government funding. And our role is to facilitate the links between academia, end users, ag-tech businesses to understand problems from end users and trying to develop solutions to those problems. We've got 4 speakers for you today. We have Karthik Ramalingam from Connected Places Catapult, who is involved with the Drone Pathfinder Catalyst program. We have Sarah Calcutt, fruit industry expert and a recently appointed non-executive director from Agri-EPI Centre. We have Hilbourne from Outfield Technologies, and we have Eliot Dixon from Agri-EPI Centre. So we're just going to run a short video, but after that we'll go through the presentations from each speaker, and then we'll have a Q&A session afterwards. So if you have any questions you'd like to pose to the panel, please put them in the comments section. And also, if you'd like to introduce yourself, please also do that in the comments section so we can see exactly who you are and where you're calling in from. So if that's okay, we can run the VT, please.
Connected Places Catapult is the UK's innovation accelerator for cities, transport and places. As part of the Department for Transport funded Drone Pathfinder Catalyst program, we are here today to showcase an innovative example of using artificial intelligence and drone technology in the agriculture sector. Connected Places Catapult has brought together partners in Barnsley Farm, BX, Agri-EPI Centre and Outfield Technologies to demonstrate how artificial intelligence, 3D mapping and drone technology can be used for getting high accuracy yield estimates and reducing fruit variability between trees in high-value crops such as orchard fruit.
So the main challenges of the traditional methods that we currently use are that they are often quite inaccurate, sometimes as much as 20% out either side on yield estimates. So when we use a uniform approach across the whole orchard, it has a higher cost because we may be over-applying. And also that's not great for the environment because we could be applying chemicals which we don't actually need to apply.
The Outfield system uses small, low-cost drones to survey an orchard quickly, generating data for growers. We can map the blossoms on the trees across the orchard, we can map the fruit on the trees across the orchard, we can also map tree size. We can then pull that information together to produce a high accuracy yield estimate for the orchard well ahead of harvest time.
Barnsley Farms are an early adopter of drone technology and AI, and it's given them a real competitive advantage in terms of gathering a lot more information about their orchards and a real depth of understanding that previously was expensive to acquire and often impossible. And it's also enabling them to take decisions quicker and smarter about how they approach their commercial markets.
This use case is a great example of how artificial intelligence and drone technology can be used for improving efficiency in the agriculture sector. However, these concepts and solutions are also highly transferable across sectors, such as fall detection in infrastructure and wildlife surveying. If you have any questions or need to know more about how drone technologies can be useful for your organization, please get in touch.
Thank you, Duncan. Good morning, everybody. It's really lovely to see so many familiar names, if not faces, in the comment bar there. Really, I'm here. I've just got a couple of slides, actually. Annabelle, if you could line those up for me, that'd be lovely. I've just got a couple of things more as a prompt to keep me on track. And as you all know, I can talk for a bit too long, so we're going to try and keep it on less than 10 minutes. First slide, please. So, I mean, everyone's seen this one before, but I had a conversation last week with a grower who's about my age, about to plant an orchard in the style that his father would have planted it. And this is one of the sort of the tragic issues that we have within the top fruit industry. And one of the reasons for such rapid change currently is that we have to stop doing the same thing over and over again because we need dramatically different results. Could we have the next slide, please? So we do need something different. we are in a complete new farming revolution. I mean, there's so much change. If you look at what's happened in the last 5 years, let alone what's happened in the last 2, a total change from a societal perspective. The political landscape is changing, policy that influences what we're doing, consumer trends with a plant-based diet change is an opportunity, but how do we meet it? We have environmental pressures rushing towards us. For those of you that sort of have read the report from British Apples and Pears about the sustainability of the British industry and where we are from an environmental perspective, I think one of the functions is today is to talk about where we are from a sustainable financial future for the sector. We've seen a lot of consolidation of the top fruit industry, and we're going to see an awful lot more after the last couple of years. Obviously, diminishing returns and the pressures on size and quality, it's a problem. Now, that consolidation then adds issues around geography. We have the challenges with labour. I mean, you're looking at staff efficiencies. I've put that on the slide, but actually the number of people that we have and their level of qualification and how much work we need them to do, everybody needs to work smarter rather than just harder. We don't want to break people. We need to make their working day more efficient. And we need that knowledge that will improve our returns. If you've just seen in Karthik's presentation there, we're looking for something for a future for top fruit growing where you've got all the information that is going to manage your costs. It's going to improve the proportion of class 1 fruit that goes in the bin. It's going to improve your understanding of what's happening in the orchards. It's going to support your agronomists. I mean, there are a lot of agronomists on the call. This is really about how you're going to support your customers. There's a huge amount of pressure around that class 2 fruit portion. Putting aside the challenges of a lot of the varieties that we need to grow commercially in the UK, perhaps not naturally growing the size profile of fruit. It's a piece of work that we did at British Apples and Pears earlier this year, looking at that sort of shift in the last sort of 5 to 10 years for a narrower size band. The multiple retailers want that efficiency of number of packs within a crate. The consumer is now looking for is being presented with an incredibly narrow size banding. And really what we're expecting our orchards to produce is 63 to 68 mil. And depending on the variety, well, we're going to get 60 to 80% of all the fruit required is going to be in that size band. So what we need to be doing is adopting this technology and using this new sort of knowledge to improve our efficiency, to improve that proportion of that 63 to 68 mil in the bin. I mean, looking at the piece of work, I mean, those of you who've been involved with British Apples and Pears and the agronomy network, I mean, this is available to a lot of people because it's the really critical piece facing the growers. So a return on gala, so the difference between the 58 to 63 mil, 16 by 6, so the crate of fruit, versus the 65 to 70 mil is a 21 pence per kilo reduction in your return. So they're getting the sizing right to getting the sizing wrong is 21p less a kilo. That is at the cost of production to below the cost of production in many instances in the industry. We can't afford to continue growing a crop that is too large for the needs of our customer. So where we come back to in this, in the purpose of this morning and the technology that's being showcased, we're looking at how we're going to improve the net return to the grower. So how your crop estimation will improve so you can manage your storage better, how the tree health is improved by greater information. Your agronomists, nobody can with the best will in their world walk every row of every orchard across the entire size of everybody's farms. They're going to look at 5 to 10% as best. So the drone technology supporting them in directing them to where they really need to be. Tom's on the call. I mean, the work that he's doing with the Helios Orchard project and where that's being replicated in other initiatives elsewhere in the industry, the amount of data that I've put knowledge is power on there, but knowledge is money in this instance. So the greater understanding of the crop loading, the tree health, the canopy density and what that's telling you about the nutritional needs, mapping that in properly with your microsoil analysis, and eventually working to a point where we're going to be treating trees on an individual basis. So coming back to the point around using less product, so that's cost efficiency, but it's also environmentally more sustainable. The public perception, we know how poor that can be. I'm going to wrap up quite early. I'm staying on the call for questions later if anybody wants to pick my brains. But you've got the people on this call this morning who'll be able to answer a lot of your questions. This obviously is not just about drones. This is about how artificial intelligence is being integrated across the rest of the industry. I'm having an amazing time having joined Agri-EPI Centre and the breadth of the projects and actually what that's going to bring to primary production, particularly in tree fruit. We've got some really interesting initiatives ahead of us. So handing back to Duncan and the rest of the team, but I'll hopefully speak to a few of you later.
Good morning, everyone. Thanks for joining us. So my name is Karthik. I'm from Canada. I'm a future aviation systems engineer at Connected Places Catapult. So I'll just give you a quick overview about what we are, Connected Places Catapult, and a little bit about the Drone Pathfinder Catalyst program, which has enabled us to be here today. Next slide, please. Connected Places Catapult is one of the nine centers in the Catapult network that was set up by the UK Technology Strategy Board to support and promote innovation by UK businesses. They bring together leading technology and innovation centers in the UK. Each Catapult center specializes in different area of technology, as you can see, and they're spread widely across the UK. We are the UK's innovation accelerator for cities, transport, and places. We are, and I would say we are a bridge between academia, the business sector, and government bodies in order to accelerate and bring in transformative and disruptive innovative technologies into the market and help UK businesses to grow their sectors. Next slide, please. The Drone Pathfinder Catalyst program is sponsored by the Department for Transport and supported by the Department for Business, Energy and Industrial Strategy and the Civil Aviation Authority. This program has been running for about a few years now. However, the aim of the whole program is to accelerate the safe adoption of drones across UK business sectors by engaging with industries and showcase the benefits of integrating drone services into the existing workflow and within the existing market sectors. We at Connected Places Catapult are in a unique position where we are recognized with our neutrality within the sector and our established academic network and history of close engagement with SMEs, governments, and regulators puts us in a unique position to be able to increase understanding of benefits drones can bring to a business, and also identify the key sectors and the drivers for various opportunities that exist within the sectors so that we can increase adoption of drones within that sector. We also aim to demonstrate use cases to increase awareness and build supporting evidence of what benefits they can provide. Also, we act as we provide an enabling environment for various industry bodies, drone service providers, regulators to be able to collaborate on best practice for safe implementation of drone technologies within the UK airspace. Next slide, please. This just provides an overview of what the three-pronged approach we have used for this program. So the three-pronged approach is the first approach is actually tackling each sector and focusing on key sectors within the UK that have a strategic importance and working with stakeholders closely to identify the benefits across these sectors. So some of them, as you can see, like housing, agriculture, and rail, which are within housing, where we have interacted with different housing societies and our different UAV operators and done a use case demonstration at the beginning of this year. The focus in the second half of this year has been to look at different sectors like agriculture and rail. The agriculture one, which we are present here to look at. For the rail sector, we have worked with Network Rail and also currently engaged in various use cases and demonstrations within those sectors. The second approach is to look at regulations and technology enablers. So, for example, the more and more automation of drones, for example, using drone-in-a-box technologies, how they can bring about the increase in efficiency and the ease of use within different sectors as these technologies are applicable across various sectors, not only housing, agriculture, rail, but across security, infrastructure inspection, etc., across many other sectors. And also to look at how they can be integrated in the current regulatory environment that exists, even in the future as we look towards beyond visual line of sight, visual line of sight technologies, and which can actually bring in more efficiencies and benefits as more and more automation and increased usage of drones can be realized. The third one is actually to look at cross-sector use cases. For example, looking at the sensor-based technologies like multispectral detection, thermal imaging, infrastructure inspection, spatial and volumetric surveying, which can be used across various sectors. So these are focused on technologies or the drone technologies themselves. Next slide, please. The methodology we have used for the drones in agriculture project currently we are undergoing is to initially talk to as many stakeholders as possible within the sector to draw out a technology and regulatory landscape or map out the landscape currently that exists and look at what opportunities there may be for drones currently and what are the best use cases which can be demonstrated, and all these benefits can be disseminated across the wider stakeholders. The second phase of the project has been to look at the actual demonstrations or the key use cases, which can be across the whole agriculture sector as well. So we've picked out a couple of use cases within that, and to actually showcase the use case feasibility as well. So that's the second phase of the project that we had looked at. The next phase of the project is actually to disseminate these findings to the end users, and also showcasing the benefits and the solutions that can be available using drones to the other stakeholders within the agriculture sector as well. Next slide, please. I would just like to highlight the key partners that we have in Agri-EPI Center and Outfield Technologies. And as you've seen from the video previously, that was shown previously, so we brought together these partners along with our with the host location that we used for the filming, which was Barnsley Farm in Kent. We have brought together all these partners to be able to showcase the benefits of using drones for orchard management, mainly to highlight how they can improve yield estimates for high value orchard crops, and also to help the growers to maximize their harvest and improve the overall efficiencies in the supply chains. Thank you.
Next up, we have Ollie Hilbourne from Outfield Technologies, who's going to give us an example of the technology they're using currently in mapping orchard fruit. Thank you, Ollie.
Thanks very much, Duncan. Good morning, everyone, and thank you very much to the Connect Places Catapult for inviting us along today, giving us the opportunity to talk. There we go, there's my slides. So good morning, my name's Ollie. I'm one of the co-founders of Outfield, and so really interesting to hear Sarah talk about the issues that the industry is facing. I'd like to talk to you a bit about Outfield, about the system we're building, and hopefully about how we're tackling some of those problems as well. So Outfield is we're a company based in Cambridge. We're building a system for management of top fruit. So we're 100% focused on top fruit crops, mostly apples and pears at the moment. And I want to talk to you a little bit about the system and how we're using drones, because drones are a big part of that, using that drone technology. So next slide, please. Thanks. So this is the Outfield system in a nutshell. This is kind of a quick overview of what the system looks like and how it works. We're using small, off-the-shelf consumer drones. That's what you see there on the left-hand side. The farmer, the grower, owns the drone, buys the drone, and they're using the Outfield system to run that drone, to operate that drone on demand when they want information about the orchard. We're using machine learning systems to interpret that drone data. So the drone is quickly gathering data across the orchard. We're using machine learning systems to extract those features, tying that data together to make maps of orchards, parameters, metrics about the orchard, performance and what's happening in the field. And then we're providing that to the grower to help them make decisions, to try and have impactful actions and help them manage the farm better. That's the idea with the system. So next slide, please. So we use drones for our data gathering, and sort of this event is tied around drone technology, and I want to take a little bit of an opportunity to talk about that and why we do that. We've got 3 drones on the left-hand side there. Those are the 3 drone systems that the Outfield system supports at the moment. And what these drones all have in common is they've all got a really high-resolution camera. They've all got a 30-minute flight time. They can all follow GPS pre-programmed waypoints. They've all got obstacle avoidance, so they won't fly themselves into buildings or trees or things like that. And you can order them all online and have them, delivered by the end of the week. And so they really represent drone technology reaching a level of maturity where we can start to use it in bigger, more complex systems to really answer and provide growers with a lot more useful and impactful data. So in the middle, we've got an example of a flight plan. That's a flight plan the Outfield system generates. It's a series of GPS waypoints that tell the drone where to go and what to do. And you simply download that from the Outfield system, pop it in your drone, and the drone will go and survey an orchard. The drone will, just a few clicks of a button, the drone will take off by itself. It will follow that waypoint flight path by itself. It will take the photos by itself. It'll come back and land by itself as well, all the while avoiding obstacles, all the while checking it's got the right batteries and all sorts of, battery power and things like that. And what that means is that sort of 95% of the time, the operator, the pilot, the farmer, whoever's using the system, doesn't need to be focused on the drone. They can take their focus away from the system. They don't need to be controlling it all the time. They just need to be there in case something goes wrong, in case there's a bit of a problem. You might just steer the drone around something or address an issue. And what that means is there's this concept of automation levels, which comes from the self-driving car industry. So I've nixed that from them. And this puts us at automation level 3, what we call conditional automation, where 95% of the time human isn't required, and it's the focus can be put onto other tasks. So that's the kind of maturity we're at with these drone systems, and that's the drone. Those are the drones that we're using to drive the data through the Outfield system. Next slide, please. So what are the things that we're trying to do with this? Why are we flying drones over orchards? One of the things we want to do is we want to give growers better tools for blossom management. There's an example picture on the left there. We know from doing from surveys and from doing counts that the number of blossoms on a tree, an apple tree in springtime, can vary threefold between 2 trees next to each other. So you get incredible variation of trees across an orchard. We want to give growers better tools for managing that variation, to drive homogeneity in blossom across the orchard, which then translates into homogeneity in fruit set across the orchard. So you're getting the right number of fruit. The number of fruit in the tree has an impact on the size of the fruit that you get, feeding into what Sarah was just saying about class 1, class 2 fruit, size bands, things like that. So a lot of this comes back to blossom management. Can we provide the growers with better insights in what's going on, and then can we take those insights, can we do something with them? That's one of the things, one of the problems we're trying to tackle here. Next slide, please. So how close are we to doing that? The answer is pretty close. In fact, we're doing that already. This is the Outfield web app. This is our system. You're looking at a heat map of an orchard there. It's a blossom loading heat map, or a blossom map of the orchard. Dark pink is where there are more blossoms on average in the orchard. Light pink where you've got fewer blossoms. There's a sample image on the side there so you can see what's going on. And something we've done this year with a couple of our users is take these maps, these heat maps, take the contours from these heat maps and turn them into prescription files that can be put into a precision sprayer, a GPS-guided sprayer, and it can trundle around the field using its GPS, using the information from this heat map to apply the chemical, the thinning agent that it needs to apply in different parts. From next season, users of the app will be able to do this in the app, so you'll be able to sort of define which contours you want and export those into your sprayer, and hopefully making that a completely seamless flow. But the idea is drone data then being interpreted in the right way, then being turned into actionable insights for growers, and creating a real workflow that goes from data gathering all the way through to taking actions. Next slide, please. It's not just blossom. We're also looking at fruit, so helping growers manage fruit, giving them tools to manage fruit throughout the season. I mean, this is the kind of view that the drone sees as it's surveying over an orchard. So you're seeing all these trees here. When you walk along the orchard, it looks very homogeneous, but when you start to look, from above, from the drone view, you start to see there's quite a difference in the size of trees and the number of fruit set on the trees. And again, that feeds into Sarah's point around making sure that we're getting right size of fruit and quantity of fruit, as well as quality of fruit, making sure they're on the right size. So next slide, please. And so that's what we're doing as well. Much like the blossom maps, we're doing these fruit maps of where we've got fruit in the orchard. Dark blue, you've got more fruit. Light blue, white, you've got fewer fruit on the orchard. You'll note there's a timeline along the bottom as well. A timeline you can pull and drag, so you can flick between different surveys. If you've got surveys over multiple seasons, you can start to compare those. If you're doing multiple surveys during a season, you can start to see that change. So taking that drone data and turning it not just into maps, but maps you can start to compare to each other. You can start to build up a picture of what's going on. And what's this showing you? I mean, this is showing you where you've got more fruit in the orchard. So that might help you with your planning your labor and sort of laying out bins and things in the orchard. It's highlighting areas of the orchard that are maybe underperforming. So, why are they underperforming? That might be a disease issue. It might be a soil issue. You can start to look at that. You can start to drill down and get a bit more information. Next slide, please. And similarly, another thing we're doing is around tree management. So now we're not looking at blossom, we're not looking at fruit, we're looking, the drone's flying a bit higher, and we're looking at the trees as a whole. So as an example, on the right-hand side, that's what the data looks like as it comes through our system. We're putting a dot down on every single tree, and we're trying to estimate the size of those trees, measure the size of those trees, and pulling all that together again into a heat map. We're a big fan of the heat map here at Outfield. This heat map is showing you average tree size across the orchard. So we've got dark green, bigger trees, light green is smaller trees. You can start to see there are some real features coming through in this orchard. And that's actually because this orchard in particular was an arable field before it was planted, and there are some leftover sort of legacy effects from the way that soil was being managed in the arable field. And so the grower can start to use that for targeted fertilizer application, maybe for root pruning, kind of trying to bring up the underperforming areas to make them perform as well as the rest of the orchard, or just focusing on those well-performing areas, going and putting more effort in there because those trees are already doing well, just giving them even more help, so helping the superstars in that orchard. So again, hopefully another useful view that you can get building on that drone data, taking it through to actionable insights. Next slide, please. And so then tying it all together, this is kind of the main thing we're driving at with the Outfield system. This is the main thing we hear back from our users that they want to see. We launched these earlier this year, so this is the first year we've been providing these to our users. These are yield estimation reports. So I've just taken a screenshot here of a PDF report the grower gets. You get it as a PDF as well as on the web app, depending on what you want. And what we're looking at here is a yield estimate for an orchard. So we're predicting 165 tons coming out of this orchard. We've got a map showing you where it's coming from. So red, your underperforming areas, green, your overperforming areas. There's a little bit of information there about how we're putting that together. So you can see there's a fruit map. The drone has gone and gathered a fruit map telling you where you've got fruit. The drone's gone and done a tree map as well. So we're looking at where you've got more trees and if there are any missing trees and things in the orchard. At the moment, size is something that's set, something determined by the grower. So the growers told us for this orchard, it's a 65 millimeter orchard, I think is what this grower said. It's a cameo orchard, 65 millimeters is what they were targeting. So they've told us that. But looking forward next year, we're going to be doing more tests and more demonstrations of systems to measure size directly from the drone. The drone is whipping around the orchard really quickly and counting all those fruit. Well, can we get the drone to also collect size data as well? So we're going to be doing a lot more on that next year. So not just measuring quantity, but also measuring quality of fruit. And these yield maps, we're able to generate these in sort of June or July, depending on the variety, depending on how the season goes. So, when the fruit reaches about 40 millimeter in size on the tree, we can start to pick them up with the drone. We're able to generate these yield reports, these yield estimates for the growers. You've got, months ahead of time, you're able to see that data. And for any of you that are, not farm focused, you're more in the sort of supply chain and further down supply chain, for you, this will be really actionable insights, getting much better information about what fruit is coming out at harvest time, quantities, qualities, all sorts of stuff there. There's loads of actions to be taken, loads of opportunities there to really drive down waste and loss throughout the picking, harvesting, packing, transport, storage processes. Loads of stuff we can do there. Next slide, please. And so that's the Outfield system. Tying all the things I've just mentioned, so blossom mapping, fruit mapping, orchard management, and yield estimates. What we're trying to do is use these drones, use the ability to whip around the orchard and gather data all the way through the season, provide information throughout the season, all these different action points to growers, helping them to grow more fruit, to be more efficient, to be more profitable, but also to overall to be more sustainable. That's what we're really trying to do here. Next slide, please. And so just as I end up, I just wanted to come back around and talk about drone technology again. I said at the beginning, it's very mature technology. We're using drones because they've reached this real level of maturity, and they absolutely have. But over the next 5 years, we're going to see them develop a lot more as well. In the next 5 years, we're going to see drones with longer flight times as battery technology improves. We're going to see cameras with even more resolution. Every year cameras come out with more and more resolution. And we're going to see more sensor packages as well. So at the moment, the Outfield system, we use RGB, red, green, blue, so just standard digital cameras like you're familiar with. We just use that as a sensor package. But hopefully over the next 5 years, I expect to see more sensor packages coming down to that consumer level and being available for everyone. In the middle there, we've got a drone in the box, and Karthik mentioned that when he was talking in his introduction at the beginning. The idea is this box might be sitting on your farm, it might be in your farmyard, and maybe once a day, maybe a couple times a week, the box is opening up, a drone is coming out of it automatically, completely autonomously. It's traveling over to the orchard where it needs to do a survey, it's gathering that data, flying back, landing in the box is closing up. The batteries are recharged in the box. The data is downloaded in the box. It's completely autonomous. So there's no human in the loop. And that takes us through to this full automation, this automation level 5, where we've completely taken the human out of the loop. And that means we're going to get a much higher cadence of data coming through the system, and much more data coming through, telling you about what's going on in the orchard. At the moment, the Outfield system, you might survey an orchard maybe 5-6 times a year, each orchard. With this kind of system, you might be getting data once a week on every single orchard on your farm, giving you updates and early warning of any problems and things all the way across the orchard. Next slide, please. So there you go. That's it. I hope that's been interesting. I'll be sticking around. There's a Q&A session after the last talk, and so I'm happy to answer any questions. There's also a little bit of a networking session at the end. If anyone's interested in learning more about the Outfield system, please do get in touch. Just reach out and get in contact with Outfield or with myself, and I'll be happy to answer any questions. Thanks very much.
That's fantastic. Thank you, Ollie. Really interesting to see how you're capturing that data, how you're using it through the platform to make growers have better access to the information and make better decisions on the back of it. Interesting you talk about the future sensors that are coming through that potentially will be even more insightful. I think that leads and feeds nicely into Eliot's presentation, who will be talking about some of the technology that Agri-EPI have already on a research and development sort of basis that we can deploy. So over to you, Eliot.
Thank you, Duncan, and thank you, Ollie. I think this does build on really nicely from what you've been talking about. So I'm Eliot Dixon. I work for Agri-EPI Centre as our data and automation lead. So I work with companies like Outfield, helping to develop their technologies, helping to test them, and helping them to create new projects to move those technologies on to the next stage, or in some cases understand how their technologies from other markets fit into agriculture. Great selection of people here today. I'm really looking forward to having a chat with everyone later. So hopefully my set of slides is useful. Can I have the next slide, please? Oh, already there. Thank you. So UAVs, historically, quite time-consuming systems, tend to be very manual, requiring significant post-processing, perhaps in some case manual takeoff and landing. We're now getting to the point where that's a lot more automated. And I think it's important for the current drivers, it's important to set the scene here, where UAVs are now moving from the place where they were manual systems towards being highly usable systems, either as streamlined software, such as Ollie's Outfield system, or potentially as a service, which is offering farmers a way to get data and information in an automated fashion as quickly as possible at low cost to them, both in time and money. Both of those are really important. Many important factors here. I think there are quite a few people here who are interested in beyond visual line of sight. That's going to be key to making this happen cheaply. Next slide, please. So in this short presentation, I'm going to go over a little bit of the current use cases for UAVs that we're currently being used in agriculture, things that are developed by our members at Agri-EPI Centre, and then we'll have a quick look at some of the new technologies that are being developed, not necessarily by our members, but things that could come along in the near future. One of these members, they're Hummingbird Technologies. I think one of them representative is present today. This use case is looking at mapping of variability in the field. So understanding the variability in the crop enables you to use variable applications and variable growing methods, eventually allowing an overall increased yield with a decreased input and therefore decreased costs and hopefully increased income. In this example here, Hummingbird is using a UAV to collect images of a lettuce field. They're then using a deep learning algorithm to detect those lettuces, extract their size, extract their position, and from that data you can create a variability map of the field. And this allows you to indicate areas where changes in nitrogen application can be made across the field to optimize overall yield. The idea of variable mapping, other companies are doing similar things, perhaps using NDVI maps to extract estimations on variability, but they're all essentially coming up with the same variability map. UAVs have a unique aspect to this on top of NDVI, which can be done with satellites, in that you can do this at per plant level, and that's what Hummingbird are really doing here. It's where they're using the capabilities of a UAV. Next slide, please. Another great application for UAVs is in pest and disease identification. You can't do this from satellite very easily at all. Or looking at other issues such as standing water. With this information, growers can take faster action to protect their eventual yield. Pest and disease identification is really well suited to UAVs because of the increased resolution they can provide, along with more frequent passes than satellites can provide as well. We can be at millimeter resolution if we really wanted to be here. In this use case, we're looking at Skip Scout, developed by DroneAg, which I'm sure many people are familiar with. And this has been designed primarily for the broadacre alga market to supplement and replace, to some extent, crop scouting, which is using a relatively cheap, commercially available UAV, very similar to Outfield's method, which allows for really simple use and with minimal training certification required. So farmers can pick this up relatively easily. Skip Scout is supplementing satellite data by finding reasons for variability in the field. So to do this, the grower simply selects the areas they want to look at in the field, take the drone to the edge of the field, press go on the app, the drone flies off, collects data at several points around the field, brings back and uploads it to the Skip Scout platform. Sometime later, the grower will then receive a report on the inspected areas, showing information such as crop cover and increasingly weed identification, allowing them to take actions quite quickly. Next slide, please. Another potential use case is in yield and quality estimation. So by estimating yield and crop quality during the season, growers can increase their income by harvesting at the optimum time and by targeting where they're going to harvest quite efficiently. Traditionally, this is quite time-intensive and highly skilled work, but remote sensing is offering a way to make this much more affordable. Outfield is doing this, and as are many of our other members, but in this use case, we're looking at Rumi, who are working on yield estimation for the dairy market. So in dairy, plate metering is really vital to be able to effectively manage your grassland stocks, allowing precise harvesting, in this case by a cattle or perhaps for silage. If you manage your grassland stocks effectively, you can be much cheaper, more efficient with your feed and your animals. Whilst it saves a lot of money, it's very time consuming. So Rumi have built a remote monitoring system using multiple sources. So some of this is satellite. They're also using a little bit of UAV data to estimate the grassland biomass without farmers ever having to enter the field. And it ends up giving the farmers the same view, the same data as they'd expect from plate metering, but without them ever having to leave the field. There's lots of research going on this, but there already is an existing product that is getting to be very popular in the market. Next slide, please. I suppose a bit of an elephant in the room here is using UAVs to take action. This is being done in other markets, largely with spray drones, but it's something that's not really caught on in the UK just yet. Largely, this is, I believe, due to regulation, because the technical capability is more or less there, and there's good reasons for this. So in the UK, it is not currently possible to for UAV to change mass during flight because there are certain risks there, security risks, and UAV is also potentially not able to deliver the accuracy and lack of drift that traditional sprayers can, although that is changing quite quickly. Because this is changing quite quickly, the HSE is currently investigating UAV spraying really closely. Some of our team are working with them. I've seen some people here today are working with the HSE to really help move this on to the next stage. Next slide, please, and another one, please. Cool. Very quickly now, because I'm running out of time, I'm also going to look at some of the technologies that are going to start entering the market, which are going to supplement the sensors we can already deploy. Outfield using a standard visual spectrum sensor. We can now take that, or very soon be able to take that onto another level. So LiDARs have been in development, so laser rangefinders across a volumetric space have been in development in robotics and automotive spaces for quite a long time. That's now really driving down the cost, especially because of the automotive use, driving down the cost of LiDARs. They used to be £15,000 to have one. You can now buy one for about £150. So it's now becoming a sensor which is really viable in the arable world. Many use cases for this. Here's an example that has come from Cranfield, who are using a sensor owned by Agri-EPI Centre. This is looking at quinoa. So photo of the quinoa on the left, a point cloud image of the quinoa on the right. That's a 3D volumetric piece of data, really. So by looking at that, you can estimate things like canopy height, on plant biomass, really important metrics for orchard growth. You can also look at tree morphology. Perhaps you can find trunk locations. And importantly, if we're trying to create digital twins of farms, create really precise maps. Next slide, please. I'm now running out of time. Another area is multispectral imaging is now becoming very common. Very, very common. It used to be very expensive, but now it's appearing even on relatively low-cost UAVs, and that trend will continue. So multispectral cameras are looking at a range of wavelengths of light, some of which are outside of the visual spectrum. This allows for specific indices to be made out of that data to detect various attributes in the field. Some examples here. So RGB, that's a standard visual image that you'd see with your own eye. NDVI, normalized difference vegetation index. A lot of people are going to be familiar with this. This is looking at plant health as a measure of vigor, effectively, and variability in the field. That doesn't necessarily say anything specific about the size of the plant. The thermal image on the right, that could be used to extract things like the CIR, color infrared. This is an indices, it's various spectrums mixed together. And this is able to identify water bodies in the field and help you spot variations in soil moisture, so you can manage soil moisture much more effectively. This can't be done really unless you're using some very clever machine learning without having a thermal sensor on your camera. So it'd be really exciting to see these starting to get wider use in the field. Next slide, please. Taking that stage further, we've got hyperspectral imaging. So multispectral is distinct bands. Hyperspectral is a very wide band cut into many, many, many smaller bands. This is allowing you to extract very specific bands of light, and those bands of light can give you unique measurements into crop issues, all with one sensor. So this example is coming from Cranfield University again, using some AEC-owned equipment at our glasshouse. And this is looking at ways to detect downy mildew using the hyperspectral camera. So on the bottom right-hand side, you can see the spectral profile. So those two lines are showing the intensity of light at various wavelengths. And you can see they've got very different profiles. Using those profiles, you can see whether a spot in the image is a white spot, or in fact, it's actually is that mildew, because that mildew has got a very specific spectral return. This same concept can be used to detect other pests, diseases, and even plant types if it can be scaled up. And it can also be used to generate some of the multispectral images we saw earlier. So whilst these sensors are currently highly expensive, they allow development of cheaper multispectral cameras, but may also one day be a very flexible sensor for in-field use. Next slide, please. Final slide, because I'm running over. Another sensor which is only just entering usage, and hopefully we'll see more of it in the future, is a solar-induced fluorescence sensor. So this basically takes the hyperspectral imaging concept one step further, and we get even finer in terms of our precision. This allows us to detect solar-induced fluorescence. This is the re-emittance of light at longer wavelengths when plants are absorbing solar energy during photosynthesis. Is very closely correlated to photosynthesis. So if you can detect this, you can surmise something about how active your plants are and how healthy they are. This is a very new generation of sensors. And this particular example is one that's able to detect this SIF signal even in broad daylight. And it's a really brand new capability, and Agri-EPI Centre are really investing in this. So whilst NDVI is normal for measuring parameter for estimating plant health, it's secondary and showing visible changes sometimes later. SIF, so solar-induced fluorescence, on the other hand, is much more direct, and it's essentially observing a plant's physiological reaction to an event. So essentially meaning that in terms of farming, an action can be taken much faster, or in terms of research, we can see the effects on the plant long before we can see it using visual means. Okay, that's all from me. I'm looking forward to talking to everyone in the networking event later. Thank you.
Brilliant. Thank you very much, Eliot. That's really highlighting the potential that's coming through, the more information that's going to gather to give us better insight into all sorts of crops. If I can ask the panelists to come back into the screen, please, so we can open up a Q&A session. We do have some previously submitted questions, but if anybody in the audience would like to have a particular point answered, please pop it in the chat, and we'll do our best to introduce that into the chat as we go through. So from me, again, I'll start off with a question, and I'm going to send this through to Karthik first. What are the benefits for growers to start adopting drone technology at a very early stage?
Sure. Thanks, Duncan. So I would say within the current regulatory environment, there is actually scope for use of drones in agriculture, and also the various cost benefits that can be realized. The early adoption of drones by growers can can also mean that growers are at a distinct advantage to realize the kind of full potential of these drone technologies, as highlighted by Ollie previously, about more automation coming into the drones itself. That when the regulatory environment progresses, and also with more and more automation coming in, the early adopters can actually learn more about the technology. And also every orchard is quite different due to the location, the wind, the environment conditions. So that gives the opportunity for the early adopters to be able to learn where, how, and when all these drones can be utilized in their orchards to actually achieve optimum efficiency. So it could be orchards, or it could be sort of other areas as well where this technology could progress in the future. So I would say early adoption of this technology provides that learning and the ability to be able to scale this or use it more effectively when the regulations progress and also more automation comes in, from my perspective.
Smashing, thank you.
Thank you.
Sarah, would you like to add anything there?
Well, just actually, it's kind of echoing what Karthik said. It's the with the rationalisation in the industry, you've got a bigger area that you're going to cover. So actually, it's the improving the management ability of your team. You know, everyone's got some. All the time, I meet some fantastically qualified, really intelligent people in our industry, and they're stretched really thin. And I think the adoption of this technology to support them doing their jobs better and to improve that return, it's a critical path now for everybody's businesses, isn't it?
Okay, thank you. Ollie, just to add a little bit more to that, would you, in your role, encourage people to fly their own drone, or would you prefer to have a sort of a drone as a service as part of your offering?
Yeah, sure. It's something we think about quite a lot. You know, we've gone down the route where we think it's more beneficial to growers for them to have their own drones and fly them. And I think especially in top fruit, or in agriculture in general, but especially in top fruit, if you're trying to do blossom mapping, right? Every orchard in the UK needs to be blossom mapped, or at least that's our philosophy. And if that's got to happen in that blossom period, which might only last 2-3 weeks, you've got to get around and do all of those orchards. Really, it needs to be a democratized, a sort of a more widespread adoption system. And we think drones are a really good way of doing that. A drone is a really good way for you as a farmer to have a high resolution camera with a high precision GPS device that you can fire off around your farm to go and ask it questions, to go and gather data all over the farm, and it will come back and you have that data you can process. That's the way we see it. So farmers owning their own drones is the route we've gone down, and that's the kind of philosophy behind our system.
Okay, Eliot, anything more to add there, or you think that's been covered?
Yeah, it's important for farmers to engage with the technology to understand it, but I think it's even more important for farmers to engage in technology early to help in its development. And we're still relatively early days in quite a few of these technologies, and developers don't necessarily understand the full requirements that farmers have and all of their needs. So by engaging early, either through Agri-EPI Centre or many other groups, or directly with technology developers like Outfield, growers can really help to develop a technology that meets their needs properly, and it's the kind of tool they actually want to be using in the future. If that's not happening, then these tools won't really be suitable for purpose. So I really encourage every grower here to talk to Ollie, talk to other people, and help them make the tool that's right for them.
Okay, smashing, thank you. And we heard earlier that sort of farm staff are a precious resource now, not just in apple orchards, but across the agricultural sector and other sectors as well. And how can we use technology to make them more efficient? Are we going to replace field walking eventually with drone flights, do you believe, or robots even? I'll send that across to you, Ollie.
Good question. I think the answer is no. I think the answer is you're always going to need that field walking. You're always going to need that some expertise, boots on the ground to look at things. But I think you can be a lot more efficient with your use of agronomist time, especially as agronomist time gets more specialized and gets more expensive, by using precision farming systems, whether that's a drone or some other system. Deploy your agronomist more intelligently. Send them to the areas where you know you've got a problem. You don't want your agronomist walking around looking for problems. You want them at the problem site, tackling the problem and working out exactly what's going on. I think that's a place that we can move this to. So you might have, using Outfield, you might have drone maps of your orchards, of your farm, highlighting problem areas, and then you might get your agronomist to come in and just look at those. And they don't need to worry about the 80%, 90% of the farm which is working really well. They just need to focus on those problem areas, get them sorted. That's the way I kind of see it.
Okay, thank you. Sarah, anything to add now? I see you're nodding your head.
No, he's just said it all. That's exactly it. You need the human element. And, you know, as brilliant as Ollie and everybody's tech is, you're still going to need a person in there just to make sure.
Okay, smashing. Eliot, again, anything that you can add in there, or you think Ollie's nailed it?
Yeah, nailed it really. Technology is only ever there to supplement the farmer. Decisions still need to be made, and they just need to have the information available.
Okay. So I think it was touched on earlier about what's next for drones and drone deployment. We're still waiting for the regulation to catch up with technology, probably. So what are the next steps for drone rollout and adoption for the UK across all sectors, really? But can I send that to Eliot? I'll start with yourself this time.
Yeah, I think there's two big areas for development, especially regulatory side. That's in spraying and beyond visual line of sight. Allowing spraying obviously opens up a whole new world of precision agriculture, and especially suitable, I think, for the orchard world we're looking at here. And it has been utilised in other markets fairly commonly. We've seen a lot of UAVs come out of China with these capabilities. The other side is beyond visual line of sight flying. I believe that that's really key for making drones deployable at scale. Having that a 500-meter limit of where you can fly really adds a high level of expense to UAV flight. Now, I know there's extra cost within beyond visual line of sight flying, but that'll be much less than what is required in terms of moving UAVs around, going into the field. If you can do it beyond visual line of sight, that makes it a lot easier, a lot cheaper, both for if it's a UAV owned by the farmer, it makes it easier for them to deploy, but more likely if it's a service that the farmer is using, that makes that service much cheaper for them to purchase.
Okay, thank you. I guess that's sort of something that you'll be looking at, Ollie, with great interest to see how that legislation changes and how you can adapt your business to take advantage of those legislation changes.
Absolutely. I would say, I'd say for us, that's really important to be involved with the Connected Places Catapult, and so with Karthik and his team, trying to keep on top of other use cases and things. Karthik mentioned the rail industry; those guys have got a massive budget, and so if I can see what they're doing this year, hopefully we can copy it next year and sort of bring that more at scale to users and at a lower price point maybe. And so yeah, really important for us to be engaged and stay on top of the technology.
Okay, thank you. That leads me very nicely into another question that was posed about what can we learn from other sectors. And I know Connected Places Catapult are working across multiple sectors, not just agriculture and horticulture. So, Karthik, is there areas that that you're involved with the Connected Places Catapult, such as the rail, construction, or utilities industry, that we can perhaps adopt some of their use cases and make better use of the technology we have for agriculture and horticulture?
Yeah, certainly. I think all the technology is quite transferable, especially the artificial intelligence side. So all that sort of improving, improving the detection aspect, etc. So I think across sectors, it's transferable, and also highlighting about the specific use case about the drone in a box, or which kind of brings in more automation from where we are currently. I think that's quite I would say appealing for currently in terms of the agriculture sector as well. Also putting together the progression and regulation, maybe the beyond visual line of sight. So I think all these put together can actually sort of increase the adoption of drones, I would say, within the sector. And Oli I know is already looking at drone in a box and how that can be used within their sort of orchard management system, and that would actually make the system sort of to be used with like much more easily, and it can be adopted much more faster as well compared to currently what the drones that would be used by the growers. So I think there's a lot of synergy that can be utilized across sectors, and we at Connected Places Catapult want to sort of enable that to be able to bring different technologies from different sectors and how that can be implemented in, say, agriculture, etc. So I think just wanted to highlight that drone in a box could be one of them that could be like have a high synergy that I can see currently with the orchard management system, I would say.
Thank you. Great, thanks. We've got a few questions in the chat now, which I'll try and run through. So I'll start. Mike Cantwell, with regards to blossom mapping, can frost effects frosting be estimated via drone technology? Which I think is probably one for you, Ollie, and perhaps Sarah, you can chip in on this one as well, maybe.
Yep, sure. So in terms of frost, unfortunately, this year has been a terrible year for frost for growers, but quite a good year for us in terms of gathering data sets and things. That might be a bit insensitive, I'm sorry, but that's how I always view these things. But we're not directly detecting frost with the drone, but what we can do is we can see areas where there's less blossom on the tree, and that might be caused by frost attacking buds, so we can pick that up. Later in the season, we can then see where you've got fewer fruit on the tree, less fruit loading, so we can see the effect of frost in that way as well. And we can also, because we've got spatial data, we can also start overlaying this with things like topology maps of orchards. So if you know there's a bit of a dip in an orchard, a bit of a frost pocket, you can start to overlay your blossom maps with that. And so I think there are things we can absolutely do there to look at blossom.
Yeah. Thank you. I don't know, Sarah, have you got anything to add on there in terms of
yeah, definitely, and also on a slightly sort of depressing side of things as well, if you've got a year like this year where we had 40% labour shortages sort of mid-season, we approached the top fruit season with just not enough people. I shouldn't think there's any grower on this call that had 100% of the labour that they required this year. And unfortunately, there is the need to have the really detailed information. If you've got to choose between one orchard and another, if you don't have enough pickers, you need to go and choose the one that's got the best crop hanging on it. And so my feeling is perhaps this kind of technology is going to really actually help refine that really awful end of the decision making. Because if you've got a marginal orchard, then you can go and do that if you've got time. But if you've got a better orchard, then that's where your better return lies. And sadly, this kind of technology, well, it's good. This technology is going to help with that decision making, but it's minimising the onward damage, isn't it, really, Duncan? It's you've had one hit, but you don't want a second one by going and picking an orchard before another that you shouldn't.
Sure, absolutely. Thank you. A question from Jim Bishop, which I'm going to take myself because it's quite an easy one. Can this technology be used into vineyards? Absolutely, yes. So I think, sorry, Jim, it's short and sweet on that one. Mike, again, pest and disease identification has been mentioned, but how far is the technology away from being able to map or estimate pest and disease, as this can cause high levels of loss in a crop? Eliot, perhaps that's something for you, talking about the hyperspectral, multispectral.
Yeah, it depends a lot on what the pest and disease is. Off the top of my head, I can't think of any product you can currently purchase or map the pest and disease directly. There's plenty of stuff you can buy which will map their effects and help you spot issues in the field, or at least see it much later on. So Skippy Scout is perhaps a good example of a pest spotting system. It can see weeds growing quite quickly. That's not exactly what you're looking for there, but that's one of the use cases. But that's pretty late on by the time that technology is currently able to spot it. Over time, that's going to get better and better. hyperspectral imaging adds a new layer of capability, and this is something where there's a lot of research going on, but I still think we're a couple of years away from seeing that. So multispectral is a cheap sensor. Hyperspectral is very expensive. If you can use a hyperspectral sensor to help you find specific wavelengths where a particular pest is quite active as compared to the crop, you'll be able to use that information to eventually design a sensor which is a lot cheaper but can do the same thing without doing everything else that the hyperspectral sensor can do. So we're not completely there yet, but things are moving on quite quickly.
Absolutely, thank you. I think that's some of the R&D work that we're hoping to be involved with to sort of help develop that technology for wider deployment. Quick question here, directed to you, Ollie, from Charles Hutton Squire, about if you're going to incorporate flights for fruit size, will you still be able to fly above, or will have to fly within the rows? So I suppose it's the angle that you're actually taking the images from.
Yep, sure. It's a good question. I mean, the answer is we're still developing a lot of that technology. The really nice thing about drones is a drone is a camera strapped onto some propellers, and you can control it. You've got huge amounts of control over it. You can send it over the tree, next to the tree, just above the tree, close to the tree. You can send it in an orbit around the tree if you want. You can film it. You can do all sorts of things. And so we're looking at, we've got a few different techniques that we're exploring at the moment for size estimation. And a big part of that is how we align the camera in the air. But that's one of the powerful, things about the drone is that you have all that control over it. So it sort of doesn't answer the question, but hopefully it does.
Okay, I think, Karthik, can you sort of add a little bit in there in terms of how that's been utilised in other sectors, and how they're flying drones and the angles and sort of that they need to take the images from?
Yeah, sure. I would say, especially with surveying buildings, or even survey of any tracks or power lines, etc. I think there also you need especially the buildings. I can think of where you need close inspection to be able to monitor the roofs, etc. For any damages or even slight cracks, etc. So you need to be quite close to those buildings and have much more maneuverability with the drone, and also get much closer to be able to analyze those. So I think those can be taken. Those aspects can actually be probably used for even sort of the closer inspection of fruits, etc. for determining their size, I would say. Which at this point I can think of is quite relevant.
Okay, thank you. I've got a couple of questions there I think have already been answered about pest and disease monitoring from Alex, so I'll skip over those, that's okay. One here from William about how does environmental factors affect sensing technologies and the accuracy of survey data, e.g. LiDAR can be affected by fog. I think Eliot, probably you're well placed to answer that one. We're aware of how satellites are affected by weather conditions. Drones give us a different level of resolution and capability.
Yeah. I used to be an autonomous vehicle engineer. I used to spend a lot of time thinking about how different sensors work in different environments. It's really important that not every sensor is suitable for all use cases. And sensor fusion in all domains, automotive is definitely one domain where it's important, but also in agriculture, sensor fusion is vital because different sensors have different capabilities. If we can use them all together in a combined way, that unlocks a much greater capability in any individual sensor alone. So like you say, Duncan, a satellite, fantastic, relatively cheap for any particular person to use because expenses spread quite widely, but at least for visual spectrum satellites, can't get through cloud cover. So in the UK, especially this year, useless most of the year round. That's where you can supplement that data with perhaps a UAV flight, which is great. LiDAR, again, great sensor, really precise. A LiDAR is there to generate. The LiDAR does two things. It either gives you a live update of where objects are around you, sensing their distance very precisely, in a point-like fashion, or it can create a highly accurate map. of your environment, which is static or at least can be updated quite slowly. Both of these are quite useful. LiDAR, though, has a major issue where it is heavily attenuated. Its current LiDARs are heavily attenuated by rain and fog. So if you're in foggy conditions, essentially the range of your LiDAR gets vastly reduced. And in rain, you're going to get fake returns quite often. So you're going to see objects that don't exist. That's quite a big issue. There are ways to process that out, but it does take quite some work. I'll keep going a little bit. So use cases for LiDAR in agriculture, I think, are primarily around robotics. A robot can use LiDAR to avoid hitting things, but also around creating really highly millimeter, pretty much accurate maps of your farm. So that's helping you to do, perhaps in an orchard, detecting very precise positions of trees, because these LiDAR maps would be geolocalized down to a few millimeters, so you can know exactly where your trees are, and you can extract those trunk positions relatively easily. It takes a bit of machine learning, it's not too bad. And because you've got that static map, every year you can create a new map, and you can start to see yearly variability in your crop as well. So you can look at biomass in your canopy, for example, or tree morphology changing from year to year, because you have that really high, very dense and very precise point cloud image.
Okay, thank you. Another question for me, and I think that just leads on a bit from what Eliot said about, we've spoken about drones and thinking drones are just about UAVs, but they're actually, drones can be all sorts of robotic devices. And how can we incorporate, other support technology to assist with growers? I'm thinking of cobots and that sort of thing. Perhaps this one for you, Sarah, that you could pick up on.
Sorry, Duncan, can you say that again? I've got a really shaky connection, so I got about a third of what you said. Sorry.
Okay, no problem. I was just picking up a bit, Eliot. We talked a little bit there about satellites and drones and how they complement one another. But drones aren't just UAVs; they're other bits of tech as well. So robots, cobots, and perhaps utilising those to for adoption to improve efficiencies on farm.
Yeah, no, absolutely. Yes, there's a soft fruit conversation I was part of last week. We're sort of looking at robot harvesting and then drone armies that will then take the fruit back to store. So you can pick 24 hours a day, and as long as everything's moving on its prescribed track, you're good. I mean, so far in top fruit, where we're looking at is a low level of AI with sort of autonomous, some autonomous tractors which are just coming to the market, which are really useful. I mean, that with twinned with some of this tech, so that sort of integrated management plan for your orchard is not very far away. In terms of top fruit picking, we're quite a long way away from actually having any sort of autonomous harvesting rigs in respect to something which are getting inside the tree to pick the fruit that's more awkward to find. But what we are getting to is a greater amount of data gathered by the rigs that people are picking onto. So we're not far away from a camera that will tell you what's in the bin. It'll survey the quality of what's going in there. There's the potential, as you do on a vegetable harvesting rig, there's a bit of grading going on. We're not that far away from a harvesting rig where we will be using this kind of sensor technology to make that quality decision, left-hand channel for class 1 and storage, right-hand channel for something that's much less cost heavy. So it's moving on. The space is moving on really quickly, and this sensor technology is intrinsic in the basic sort of the robotic element of the transport and movement of product is coming too.
Okay, thank you. I was thinking also about we've mentioned spray technology or using drones for spraying, but certainly using robots for spraying is not that far away, I guess. If we're creating some really good maps with drones and with satellite, that we can then use robots to actually go out and do the intervention measures. Yeah, I mean, I mentioned earlier the project that Tom Hume is hosting, so that's not very far away as well from with Seymour's with their sprayer technology, not very far away from a really small area of data. So 20 cubic centimeters was quoted as being on the horizon, and you're treating one tree and not the next. And the same way that the drone tech we're talking about in terms of crop estimation, actually then adding this layer of surveying in there, going, well, you can treat this tree, so you can go back going, well, of my 2,500 trees a hectare or whatever, I'm only going to treat 600 of them. And also
it's crop efficiency and it's crop quality, isn't it? Because you stop the issue before it affects the whole lot.
Sure. No, thank you. Another question's coming from Alex Radu from Agri-Vista, I think, aimed at you, Eliot. So regarding pest and disease monitoring with remote sensing, I suppose basically it's distinguishing the difference between something that's caused by a pathogen and something that's caused by nutrition. And is that possible to identify the differences with a hyperspectral wavelength?
Yeah, I'll just write a reply to this in the chat, but I'll answer it here anyway. So all pests and diseases will interact with light in a way which is unique to them. So some of that you can see with the naked eye. So say that mildew example earlier, that's appearing as a white spot, and you can see that difference quite easily with your own eye against the plant. Now, that interaction with light extends into parts of the spectrum that you can't see with your own eye, and going off into infrared and off into the UV ends of the spectrum. With a hyperspectral camera, you can see into those areas. And that means that every pest and disease creates, and plant creates a unique, say, signal or fingerprint influence on the light spectrum. If you can then understand what that fingerprint is for a specific disease, you can start to detect that amongst a larger signal. Now, obviously, if your influence of the disease is quite small and you're a long way off, you're going to struggle to see it unless you've got an absolutely amazing sensor. But if you're relatively close or the disease influence is quite strong, you're going to start seeing the influence of that pest in that signal quite easily. So obviously, hyperspectral sensors, they're very powerful for that, and it allows you to differentiate potentially between multiple different diseases. They're also highly expensive, at least currently. So what needs to happen is either the price of those goes down, or we start developing much cheaper sensors which are very sensitive to specific bands of light which indicate certain things going on. So that's what happens to multispectral sensor. There's a specific set of bands of light which can indicate multiple different things. If combined in different ways, they're generally quite non-specific, but potentially, and there are projects going on, especially at Cranfield, to try and work towards developing sensors which are taking the multispectral concept and shifting those bands of light into areas which you know are indicative of a certain pest or disease as compared to the crop.
Smashing, thank you. Well, I think we've actually just slightly overrun our time for a Q&A, but I want to just thank all of you for participating. Thank you for your presentations, and also thank you for the questions that have come in through the comments box. We are going to sort of jump out of this now and jump into the other platform which you as delegates are all sitting on. So if you don't mind just bearing with us for a minute or so while we jump out of this and jump into the other one, we'll be happy to network with you and take individual questions if that's possible in the networking platform. So again, thank you very much for joining us. I hope you've enjoyed it. I hope it's been insightful. Certainly has been for me. And thank you again for the presentations. Really kind of everyone to be involved. I'm just going to stay on here for a minute or two until the others jump across. So I haven't got a song and dance act, but I'll smile nicely at you.